If you don't know us, we're a smallish foreign exchange, well, a few other things. The M was originally multi-asset, but pretty much foreign exchange trading platform, open to public, hedge funds, banks alike, trying to create a bit of a democratized platform for trading. And the result of that is that for us, dealing with information, dealing with data reactively isn't just an option, isn't just a fashion, it's not a fad. It's without doing it, we don't have a business. It's absolutely critical. So talking about trading, there was a little show of hands for people in finance. Who considers themselves familiar with how financial markets operate? So I can lie with moderate impunity. Okay. So I am going to give away something today. Forget the other prizes, forget the coupon ticket. I'm going to give away the secret of successful trading. Now, to get advice like this, you would normally have to pay quite a lot to go on a private course, or at the very least, set your spam filter to extremely tolerant. So, I am, for the people in the room who are from finance and from, think they understand the markets, I'm simplifying very, very slightly, but only slightly. And this is basically it. I want to buy at a lower price than I eventually sell. Now, depending on the level of paranoia of your regulator and depending on the instruments you're trading in, you may be able to reverse that timescale and actually sell the thing first and then buy it later. And in that case, the trick is to do it at the reverse of the prices. And in the middle of these, don't panic. Don't panic is very important. This is why most people lose money. Now, this is a massive simplification of the market, but actually buried in this very trivial diagram is pretty much, as well as everything you need to know about successful trading, and you're welcome, it's everything you need to know about what makes this hard for an organization that's running a trading platform. And this is because to make this work, I can't rely on just buyers and sellers turning up at pretty much any time they like. I cannot run this like, for example, eBay. If there is this imaginary line that traces the true value of something, then actually there needs to be someone representing that true value at all points in time. So I need to form that market. And generally I form that, and I promise we'll be very light on animation here. I form that from a combination of participants. Now, there's a whole set of buyers and a whole set of sellers, and the bold line in the middle, the one we originally saw and cared about, is basically just the combination of the two. It's the price the highest buyer is willing to pay versus the price the lowest seller is willing to accept. So, I mean, the normal market sort of stasis, the prices we were seeing flickering up and down on the screens earlier, that's basically stalemate. That is when no one is actually crossing. And every so often, a buyer will pay a little more, a seller will accept a little less, and hey, trade happens. Now, to do this, as I said, I can't just to get this happening continuously, so to have that price available at all times such that, when we get this dip and you decide, actually, I am going to panic, or we get this slight raise and you think, good enough for me, I'm going to take my money and run, there's someone there to sell to. And if I can't rely on just other clients of the system, then I need someone permanently there providing prices. And we call those people market makers. If you are unfamiliar with the idea of a market maker, it's very simple. Who knows what a market maker is? This isn't going to affect anything I say, basically. It's just to get you to move, because it's the afternoon. All right, anyone queued up for a concert, or a theatre, or a stage show, and been approached by a ticket tout? Tickets bought or sold? Yes? More familiar than market maker or less? More. Okay. That's market making. No offense to our sponsors, Morgan Stanley here, who do market make for us, sorry. Market making is basically the same as ticket touting. What you're doing is you have no interest in holding the ticket at the end of the day. If I'm a good ticket tout, and when the show starts, I've got a big pile of tickets, I've lost money. I've bought more than I sold. All I want to do is buy for a slightly lower price, sell for a slightly higher price, and end the day with nothing, no stock at all. And that's market making. So market making, ticket touting, roughly the same thing. They enable the market to function. Now, for our market makers to compete, they need a few things. They need us to be reliable. They need us to be scalable. They need us to be responsive. We've heard this somewhere before this week. And that directly affects the bottom line for us. The more observant of you may have noticed there were two lines. Yeah, I buy on the red line, I buy at a slightly higher price because that's the lowest current price a seller will accept, and I sell on the blue line. Yeah, the highest current price a buyer is willing to pay. So the difference between those, which we normally call the market spread, is a result of the efficiency of those market makers. It's a result of two things. Firstly, lots of people competing and differing opinions, creating a smaller and smaller gap in the middle. And the other is confidence. If I'm a market maker, if I want to be a successful tout, if I want to end up the day with no tickets, buy, sell, buy, sell, buy, sell, I need to be pretty aggressive. I need to put my prices really tight together to make sure that I'm currently offering the best prices and I have the best chance of hitting all the buyers and hitting all the sellers and having no tickets left to deal with when the concert starts. However, if my prices are really tight together and the market moves suddenly and I can't react quickly enough, I am stuffed, because what will happen is someone will come in very quickly, very smartly, and we're one of the companies that enables this. If anyone's read the press about high-frequency trading, ruining the global economy and destabilizing things, sorry, our bad, we're there. It's right up there with dangerous dogs and single mothers. So the only way we can, the market makers can protect themselves from someone basically stealing their lunch when they're offering very tight competitive prices is to be able to update those prices quickly and reliably. Again, we heard this earlier today, we've heard several times about reliable latency is better than low latency. And the ideal is to have both. So our markets are directly affected. The effectiveness of our market, that spread that as a customer I'd rather not pay to buy and sell and realize on my plan, is directly affected by the latency that market can operate with and the reliability we can offer to clients and market makers, so all the participants. And this was basically where our next came from. We decided we were going to do this. It's already being done. We were going to just be a little fairer and open and cleaner and try offer a slightly more democratic marketplace than anyone else was going to offer. And it was a green field. It was marvelous. We had blank slate for technology, blank slate for the business, because actually no one had quite played this model, the sort of exchange-based model, the collaborative trading in finance before. Most of it is basically a slightly rigged game. You're playing against the house. And not quite a blank check, but a reasonably healthy investor. So that was a great place to start. And our vision was, this landscape that was going to be, a brave new dawn of the best strategy and the best technology wins. It was something like this. It was just going to be about the superior use of the technology, and probably had to recalibrate that a little bit. Maybe something like this: gleaming rooms of servers, clicking away, algorithms fighting to the death, and best man left standing. It turns out what you get if you actually run that as a business, and yet we tried, is you get a bloodbath. The reality of running a financial exchange is much more like this. It's a managed ecosystem. Basically, I can't let the lions eat all the elephants. I can't let the elephants get out of control, rampage, and strip all the vegetation and trample the trees. I need a certain amount of give and take on both sides, and ideally no tourists get killed. We don't have, we'd love to have, but we don't actually have a democratic environment. I have different participants, basic clients and market makers, with different commitments, different responsibilities, and different roles. I can't manage that as a completely free market. It just doesn't work. We tried it. What you get is a very, very brief and exciting spike of activity, followed by insolvency, which no good for any of us, really. So we adjusted our vision, moved on. So one of the downsides of a clean slate is plenty of room for making mistakes, and we've done that in the technology, we've done that in the business. And this is kind of one of our biggest learning points, I think, in what we were trying to run. It doesn't really affect whether it needed to be reactive or not. It still did. So why does it need to be reactive? What's sort of driving us? So I took some figures, these are from March, and over a recent week, we actually serve thousands of clients. You're deeply unimpressed, I can tell. That's not a huge number. It's certainly not where we expected to be. As I say, you never quite, in a startup, you never quite end up with the business you imagined. We thought we would be mass retail, loads of people signing in over the internet, war on the matrix, banks. Didn't happen. We've ended up as much more of a B2B business. We've got brokers, actually people who we thought originally were our competition are now our clients, as well as individuals, hedge funds, small groups. So we've got a concentration of trading in a smaller number of clients. And that concentration of trading, this is still 100,000 trades. Again, this is over a week. That's again, not a terribly impressive number. Nothing really to worry about there. And if you remember the chart, there were 2 trades on that. The hard bit is the line when nothing else is happening, because I have to keep that line pulsing, and I have to keep that line going out. So to generate these 100,000 trades, we get about 100 million price updates. It's in the hundreds of millions. I think the week I was looking at was about 500 million, something in that region. And this is an instruction from a client or a market maker to say, no, don't like that price, move it. Put it somewhere else. Pull that offer, put in a new one. Again, all the flashing lights we were seeing, all the flashing numbers we were seeing on the reactive trader, those are the sort of numbers we're dealing with. And I have to get that data to the clients so they can see the line move and decide whether or not it's time to panic and whether they want to stay in the market or move out. And they're on the internet, so we sort of talk glibly about broadcasting this data. Well, we're not broadcasting. Broadcasting would be lovely. I mean, broadcasting would be a bliss. We are doing parallel unicast, because that's how TCP/IP works. So we are pushing out about 10 billion price updates. I measured this the other day. It's about 4.5 terabytes of market data a week going out. And that's to every client. And there is value in that data for us. Sorry, that's across the client base. Possibly different to every client because, we saw earlier, the client cannot generally deal with the saturation of market data that's coming down to it. We've found our approach to this is to manage and regulate that at source. So actually the data that goes to every client is a slightly different version of the truth, or a slightly different set of samples of the truth. And there is still value in what data went to what client in terms of servicing their use of the exchange, because it's one thing to just do this. The hardest thing we've found is actually it wasn't where we thought the problem would be. It's improving to the clients that we are actually doing this fairly and transparently and evenly and giving them the best service they can expect. Because generally when it goes wrong, the first people the clients look to are us to blame. That trade was slow, that price was out of date, why didn't my order happen? And we have to have absolutely rock-solid evidence for why it happened that way. Firstly, to keep the client happy, first and foremost, but secondly, to keep the regulator happy, because otherwise we lose our license and we stop trading. So to do this, to manage the information that sits under all of this, I want to introduce the idea of a life cycle of data. This isn't a methodology, this isn't a framework, it's a thought model. It's a way of approaching state. Now, we've talked a lot about state and programs, and I just want to have a basic idea of what I mean by data versus just the state that you may have inside your application at any point in time. This used to be really easy. My first programming language was COBOL. I'm older than I look, or maybe not. It was really easy in COBOL. You knew where you were. That was a program. Data was stuff in files. It even had a little section at the beginning that told you what the data looked like, that separated the program neatly from the data. No blur at all. Data, I think, still exists, even though you have the idea of the application running across thousands of nodes, seamlessly chatting to each other and reporting failures. To me, data is the stuff that you still have when you've turned everything off. Power it up again, that's what's left. It's also the stuff that is an absolute bugger to refactor. Yeah, if you're playing in your IDE and you've changed your whole worldview and shifted it, and you've got this wonderful new model, data is the bit that makes that hard because you've got 3 months, 6 months, in our case now 4 years of existing state that has to shift over to that new model. So it's the stuff that's left around. And the life cycle for me has been a useful way of thinking about how we deal with data. So, early life. I didn't just choose this for the cheap laugh. I didn't even get the cheap laugh, but I certainly didn't even choose this just for the cheap laugh. This is actually quite representative to me of the early life of our data. It's short bursts. I mean, there's bursts of frantic activity that result more or less in nothing most of the time. Most of our data goes nowhere. Brief activity, dies, goes away, has no long-lasting impact. This is the transactional stuff. This is people trading. This is a price going up, someone deciding to take that price, the price being cancelled because it's changed. It's all the fast, flashing, moving stuff. To bring it back down to earth, something a little more tangible, this is going to the ATM. Yeah, all right, admittedly, in our case, mostly all you'd ever be doing is checking your balance. But this is the transaction. You expect it to be accurate. You expect it to be uncontended. You have certain expectations about the response time. You certainly don't expect it to have an ambiguous result. You think you should be pretty confident that the balance they're telling you is the balance that's available. So it's those very short, bursty, top-tier transactions. For us, we characterize this as the working set. It's the data that we're doing most of our intensive, frantic activity on. And it's highly reactive, and the small r is intentional. This is reactive in the sense of chemistry. This is the stuff that mutates, it alters. Things impinge on this data, and it has a response to it. This is where all the events are coalescing, and more events are being emitted, and the internal state is moving on. For us, at least, and again, I'm not trying to say build your systems this way. This is very much my experience, take it or leave it. For us, this is quite a small data set. Hundreds of thousands to millions of data points. It's not that hard. The lifetimes are typically fairly short. Actually, in most cases, remarkably predictably short, around 60 to 100 milliseconds. But there's a horrible tail on that distribution. We have one client who I think has an open position from, I think it's August 2010. And that's still in our working set because it can still mutate. So early life for me isn't really so much something you measure on a clock. It's something you measure on a scale of evolution. It's whether that data can still change. Is it still active? Is it still going to do anything? And this is where we have our most aggressive requirements, and we're trying to do the fastest thing with the data that's hardest to look after because it's also highly contended. There's a very good chance we trade FX. There are only, all right, you can come up with about 800 currency crosses if you try hard. If you look at the ones that are really traded, it's less than 100. The majority of that were Europe-based, so the euro has done us no favors in terms of contention. We used to have a lot more currencies to trade with dollar. It's now all in euro-dollar. So we basically have euro-dollar, euro-sterling, euro-pound. That probably makes up 80% of our volume. A lot of the rest is in gold. So the chance that any one event will change the world for the event behind it is actually pretty high. And that's a bugger to deal with if you're going to play with eventual consistency. Works for some of our areas, but certainly not for this one. Now, I'm not going to talk too much about the model we use for the application, but to make this persistent, we ended up going with a very custom solution. We did look at some products at the time, and I'm not saying there isn't something out there that would have worked for us, and certainly not something out there that would work for us now. We started this 7 years ago. We had to choose something that we knew we could build with a team, we could hire and employ and scale somewhat. So not all of these decisions were ever made in a vacuum of technical purity. We had the kind of VC pressure that says you really can have a baby in a month with 9 women, throw more bodies at it. So we had to make some choices about what we could do. And after I'd say probably a non-exhaustive study of what was out in the market, we decided to build this ourselves. And what we built was effectively a journaling system. Anyone who's read any of Martin's work on Disruptor will have picked up that, kind of like single-threaded stuff. Martin was sort of with us at the beginning of this, and the whole way we have made this work is to bring this massive events, sequence them, and play them through. And that is at the core of how all of our data management works, is that I've got a single deterministic thread. Now, I need to make that data, which means it needs to be there when you turn the machine off, so we journal that single deterministic thread. We don't bother waiting for the disk write to come back and say we're finished. We journal it in 2 places at once. Actually, we journal it in about 4 places at once, and then we send it over the wire to a DR site and journal it somewhere else. But it's n places where n is at least greater than 1, and how much greater you're willing to go to is basically a matter of capital. How many machines do you want to throw at this? But each one of them is entirely processing the data in an entirely deterministic way, and each one of them is recoverable. So we have, hit we hit our resilience target with that. Doesn't really improve responsiveness. We found actually we got enough responsiveness out of simply that single thread doing simple stuff in an uncontended way. We are able, I think if we let it loose, it would probably run a few million transactions a second. We can't feed data into it that fast. It's not the bottleneck in the system. So anyone who, I think anyone says you can't do complicated stuff on a single thread, I would beg to differ. So our systems in memory, there was a time not that long ago, God, I remember conferences 4 or 5 years ago when just saying, in memory, that was good enough. In memory, that was definitely fast. In memory, that would be cool. Your system was going to be much better than anything else. And we've seen again and again this sort of fractal pattern of tuning going on. So when we talk about data being in memory isn't enough. So, all right, I'm no longer waiting for an I/O wait. I no longer have to, no longer worry about physical I/O. I mean, that really sounds quite quaint now, doesn't it? It's like I churn my own butter, or I weaved this shirt. I wait for disk writes. No, it's all in memory, but we still wait for memory contention. There's garbage collection. You just move up the scale. Process swap, thread wake up, cache miss. The pattern repeats itself again and again. And I think if you take nothing else away from some of these talks, the fact that what we're doing in memory now we did in disk 10 years ago is a valuable one to go away with. Those patterns keep repeating themselves. So to feel comfortable that we were on top of all of that, it meant custom collections, custom high availability, custom durability. It was custom all the way down. And that brings its own challenge. The great side, and I mean, I'm a person who spent a lot of my life fighting with Oracle, not on a kind of corporate scale, but just the product. I don't mind it as a database. It's all that stuff you don't want that gets in the way of doing a good job, and you can't turn the damn thing off. And one of the comforts of actually having a custom build here, despite the challenge of doing it, was that ultimately it was down to us to fix. If it didn't work, it was in our power to fix it. It wasn't somewhere over in Redwood Shores or Seattle or wherever, choose your venue, where it was out of our hands and basically, not their core problem. People don't really do that sort of stuff. Sorry. It was our problem to fix. The downside, I mentioned hiring a team. There are human problems here. If you get a team of people who, a whole team, who are the sort of people to whom this appeals as a challenge, who are the sort of people who are competent at delivering on that challenge, that brings its own difficulties. There's a certain amount of cat herding, a certain, possibly too many creatives in the room. That has been a challenge. But what do we come out with here? I'm asked often, what does good look like? What's my, how do we think we've succeeded on this? And it's a hard question. What does a good look like? So, like everyone else, I went to the internet because that should know what good looks like. And this is apparently what good looks like. A beard in which you could comfortably hide a badger. This is actually Nigel Richards. He is I think from New Zealand and is the world Scrabble champion. And this is what this is what I hit last night after that inspiring Hemingway quote. looking for what good looks like and filtering out pictures of cats, sports stuff, because that's just a bit obvious, and anything that was fundamentally directly offensive. And again, this isn't just there for the giggles. There's a slight serious point that actually this is the ultimate end of unstructured data. Yeah. So the internet and Google, it is to me that is the zenith of an unstructured data source, which is great, except you can't ask it hard questions. So good for us looked really like order one algorithms. So I would like my matching, I would like my risk checks, I would like all the things I have to do to be order one, if possible. The next choice is normally order log n, because I don't want to go straight to order n. I do get bored of the sound of my own voice. So how do we go from order n to order log n? Normally. Beards help. Trees. Typically, if you've got an n problem, the typical way to make it order n is to put it into some kind of log tree or B tree, something that basically says it's the log n comes from the power of 2, which is the number of levels of directory or tree you have to scan to get to your thing that is still n wide. You haven't taken the n-ness away, you've taken the scanning of n away. There's cost in maintaining a tree. So if I know what n is, I can make intelligent decisions about that cost. Sometimes it may not be worth actually paying the bill of going from n to log n if n is 1 with a outlier of 2. You just deal with the outliers, and sometimes your performance won't be quite what you expect it to be. And I think one of the critical things we came away with was what you need is actually a budget for this. Now, you need some idea of how many bad executions are enough. Now, we started with an utterly meaningless SLA. I mean, we had the sort of thing that comes out when you put lawyers, bankers, and MBAs in the same room. You get an unbelievably complicated document, utterly impenetrable, and frankly no use to anybody unless you can actually go to court, which was sort of what it was there to protect everyone around. So our original punt was 10 milliseconds mean. 10 milliseconds is way too slow, it turns out, as we've studied the way the market works. Second, mean, I think we've already learned yesterday, it's a nonsense number. What we find works for us at the moment is 90th percentile, so 9 out of 10 operations within a few hundred microseconds, and 99.99 percentile at under 4 milliseconds. So one time in 10,000, an operation will take more than 4 milliseconds. And that is a mixture of order one and throwing in a few order n problems, simply because where n is high, it's not high often enough to worry about. But it's hard to get that kind of budget until you see n. It's very hard to build these data structures effectively unless you know what the business is going to look like. In terms of knowing what the business is going to look like, it's also very hard to see that if in this structure you've built, in this marvelous in-memory data model, there is no discernible domain anymore. Now, that's very interesting. I was sort of biting my tongue this morning and really interested and challenged by the presentation. But I still want to see something in my state model that is recognizably the business, or at least can separate the canonical business model from the technology of the implementation. So if I have a list of things and that list is sorted, but the sorting is purely a mechanical implementation, that sorting shouldn't really affect the representation. I ought to be able to separate those two. More often than not, the mistakes we've made is what we have when we try to export the canonical data from this model is we have something that is probably better described as a core dump than anything else. It's hard to read, hard to interpret, hard to work with as data. And so we have made the mistakes here of losing some of the dataness. So that was early life. Is everyone with me so far? Well, I'm really happy to take questions at any point. By the way, I do get bored of the sound of my own voice. So after early life, downer. I started with middle-aged and various, try to come up with some good explanations of what this next stage looks like. But it is basically dead. For us, the data has spent all its active time in that working set, in memory, but persisted in a reconstructible manner, being mutated, generating new events, reacting. And once it's done, it's done. It's never going to change again. It is a fact now. It is entered, it is part of history. So if the early life was going to your bank statement, if the early life was going to the ATM, this is basically receiving and reviewing your bank statement like we all do every month to check it's accurate. Or at the end of the year, reviewing all your bank statements on about January the 29th to try and fill in your tax return and find the terrible missing thing that will actually allow you to sort of offset some expenses. It's looking at static data. Typically, the consumers of this are human. You're making decisions, but none of that is changing. Now, there were two reasons we couldn't just do this with the same technology. Have an in-memory system, the usual limit that comes to mind is not enough memory. We'll run out. That's the obvious one. More memory management costs, eventually even more capital costs. You cannot go on adding memory indefinitely. Actually, that wasn't the killer for us. The killer is we can't ask that model really hard, long-running questions, because that model has to accept something, process it, and emit it in a few hundred microseconds. If I put in the, tell me what customers did last month kind of question to that, or tell me about all my transactions on $yen, I'm interested kind of question, into there, that does not fit with that sort of profile. We could not find a way of serving both of those loads out of the same data source. In some cases, for some of the hard, long-running questions, we decided it was actually worth building a second copy. I think there was a question yesterday about how worried are you about duplicating data? In our case, actually not terribly worried at all, because we have these data streams, we know how to process them deterministically. As long as I have a single writer, I really don't care how many copies of data I have around the place. And again, as long as that's not going to get updated massively frequently, it's a manageable thing. So we have a few instances where we take our event streams, we populate separate memory states with them, and serve different purposes with them. Drives the systems people nuts. They would really like one big box, which is the only one that has to be plugged into the fire hose and is the only one that has to cope with this massive flood of data, doing everything. From a software perspective, we'd love separation of concerns, we'd like independence, we'd like these things to operate separately and have no awareness of each other, and we write simpler, more effective software that way. We have that fight at least once a month. So characteristics of postmortem data. Dead data. It's a harsh way to describe it, but it's very inactive, inert maybe, but there were no good pictures for inert. When you're looking at it, you can't really say, no, you can only see 6 months. I want to see all of it. I want to look at all my data. Possibly that's a reasonable request. I am being investigated by the Inland Revenue. I need all my transaction history in order to substantiate my capital gains tax claim. It's structured. Generally quite highly structured data. It's fairly easy to manage. It's trades, commission charges, overnight financing. These are bank statement entries. Think of those. They follow a fairly predictable pattern. The analysis is exact. It's not, I made about $200 on that trade. It's very detailed, very exact, fairly easy to scan, and the evolution of the model for me is one of the things that really separates these areas. The model evolves only if I'm going to do something different on the whole. I need to store different data to do different stuff. And for us, and it bugs me that I feel the need to apologize for this, but we stick this in a SQL database. It works well. I think we managed to archive, once it's dead, once it's finished, once it's never going to change again, we can run 100, 200,000, possibly push to 500,000 inserts a second, stream it out, read it in a very uncontended way. We've knocked away all the costs of reconsistency because we never update anything, if we can possibly avoid it. We just write it out. It is an archive for us. It's an indexed archive, it's searchable and readable, but it works really well for us. Frankly, we had enough technology risk anywhere else. And when I say SQL database, I really mean something that you insert and select. I'd really stop there. I do not mean a compromised object store. I do not mean an application server hiding under the hood or the master of all data and integrity and management and business rules. I just want somewhere to write data and read it back easily. And I've got loads of tools for it. If you are worried about SQL databases, find the people who are working with them, remove the D, F, and G keys from their keyboard. It will really limit the damage they can do. You get down to a very workable instruction set. I'll let you think about that one. I say that's worked for us fairly well. It's easy to scale, easy to shard. It's a known quantity. And so we had enough other problems to deal with. And what does good look like here? I couldn't resist the Scrabble praise. First national champion in Scrabble in both Spanish and English. Good here is it's fit for purpose. So the response times are less challenging, but again, no one will accept anything that takes more than 2 seconds. Go away, get bored. So we need to service requests in a way that is acceptable to clients and also doesn't interfere with the high-speed traffic that's coming in to actually push market data out to them and accept their trades. It means I can take these unpredictable load where it happens out of the critical path. It means I can do support queries. And more often than not, the reason we go to our database isn't actually for the client-facing features it supports. It's because we want to investigate something that's happened unexpectedly. And it's a damn sight easier to run ad hoc queries on SQL than it is on a Java memory structure without causing pausing and other fairly toxic side effects. The other thing is stability, fault tolerance. We should be able to run if we lose a node. Actually, we should be able to run, give or take loss of a few services, if we lose the database. It's not doing the trading. It's not doing the market data. You might have trouble logging in, but basically the system should keep running. And that's what good looks like to me. It's an archive. It is doing its archiving. If I lose it, provided I can buffer up events, it's still there, and I can ask the archive hard questions. So that's where my dead data goes. Interesting, once you have alive and dead, once you have 2 stages, you've introduced an aging concept. There are loads of cheesy pictures on the internet about passing batons. I find dropping them is the more interesting case. I need a way to move things from one state to another. I need transactions. Basically, I need a reliable way of messaging. And we need that in the rest of our system, and that's the same reliability that says the gateway sent the instruction to the trading engine and the trading engine matched it and sent the instruction back to the client is how we pass data between our services. But I don't know, I think as a generation we've been damaged slightly by managed persistence because transactions were something we just didn't have to think about. I put, at something above my method and magic happened. The transactions were just looked after in the background, didn't really need to think about it. When you're distributing data, certainly when you're building your own high availability, you have to think quite hard about transactions. We certainly did. Because we could say, we'll back off the protocol. Fix has message recovery. Fix, if you don't know it, is the protocol most widely used in financial trading. Sending in orders, receiving market data, receiving news about how your order is faring in the market. TCP, IP, that's reliable too. That does resends. Or I could have a message interconnect and have that reliable. Which is great. This is all true. You can even try hard enough and you can get a reliable multicast. But none of that tells you all that tells you is the message has moved. It doesn't tell you the application has actually done anything with it. So for us, a transaction doesn't just mean I received the message. It means I received the message. I dealt with that message appropriately. I have updated or adjusted my internal state. I have pushed something out, and I have responded. And all of those events are atomic. Independent's fairly easy because we run them on a single stream. Durable is fine because they're persisted to disk as the instruction. But they're all or nothing. I need to accept the thing and be able to reproduce my outputs. And that's a basic contract all of our services honor. They either know they've received an instruction and are able to reproduce their response to that instruction, or they know they never received it at all and they'll deal with deduplication and detecting gaps. After being dead for long enough, we kind of enter history. We start to become part of the greater past, and this is, again, to take the bank statement analogy to its final conclusion, this isn't so much you looking at your bank statement, this is your bank looking at all its customers' bank statements for the past 12 years to work out how much to set aside for PPI mis-selling. This is the big, it's the extension of big complicated questions. This is even bigger, somewhat more complicated questions. And this, for us, is the last place that we're trying to really contain and tame and manage data. This is where we're still sort of saying, well, we understand data in the same way as I say I understand building a bridge as an engineer, as opposed to saying, oh, I understand weather as a meteorologist. That's a certain amount of informed guesswork and assumptions and predictions. This is where we're still trying to tame it. And possibly that's wrong. I think people making a big deal about what exchange rate you used to give the internal management reporting value of 3 years ago's profit it's questionably useful, but it's a habit that's hard to kick, particularly with the accountants. So the characteristics here, it's like a slightly refined set of the dead data. It's just deader. To make it survive longer, we find we have a more abstracted model. We're dealing with fairly pure business concepts rather than transaction concepts. Customers, money, counts of events, profits. We scan it differently, but actually this is still fitting into a fairly well-structured model. And the model evolves, but again, only as quickly as our domain evolves. We need to add a fundamentally new concept and need to change this model. And that's really neat. All fits. 3 stages. Life, death, and history. Surely there could be nothing else in there that didn't. So, I have some time left, and I have set the lead up. There's stuff that didn't fit. We have that model for really the data we thought about, in the first few months of the project, the first story cards we played, the things we really cared about and thought, here's where the hard bit will be. How do I make a risk calculation for someone who's got 2,000 open orders, order 1? That's fun. The difficult data is the stuff that just doesn't fit into any of those platforms, and any of those shapes. And the difficult data is actually, for us, it turns out, where all the real challenges have been. And the sort of stuff I'm thinking about is things like audit trails, event logs, and metrics, because how do you know you're responsive if you're not measuring it? And how do you know what's good to measure unless you're measuring everything? I talked about sending that market data out to client, those terabytes a week. Unless I actually know everything that went to that client and the behavior of the messages sent to those clients, how do I know I'm providing them a decent service? If I'm waiting for them to complain that the data they receive is out of date or shows high latency, it's too late, I've already lost. In a competitive market, they'll have gone somewhere else. So difficult data for me it's the big stuff. Yeah, sorry, there was going to be big data sooner or later. Structure's harder. It doesn't follow nice, safe rules. I don't know how people are going to navigate this. And often the structure mutates far faster than what I want to do. For me, difficult data, in terms of the 3 stages I had before, the stuff that doesn't fit into this is the things where actually I've just got totally different shaped data, but I want to do the same stuff with it. I want to review audit trails. I don't care if you're auditing something new. I just want to be able to see it. And from a software development perspective, that should be pretty much free. That shouldn't be hard. The other thing is migration is a killer. You can't migrate this data. Same way you can't back it up. Backup is up there with disk I/O. It's quaint. We have tapes in the office to show the auditors. This is all they do. The auditors come in and say, do you have backups? So, yes, we have backups. Someone literally takes them off-site every week. Do nothing with them. It's pointless. Backup is the other copy you have already populated. It's because you're resilient. So this is where we'd expect to see the big NoSQL solution, yeah? All waiting for it. And I apologize to the NoSQL group of the Netherlands. They have the nicest NoSQL logo. All the others are honestly quite dull. And I didn't want to pick a particular company because actually, I have no beef with the individual products in this space. I don't, however, like NoSQL as an idea because I think it's sloppy thinking. It's sort of like saying, hey, no curly brackets. That would be a good way to do things. NoSQL tells me my data isn't table-shaped. I absolutely accept that that's a problem space, but it doesn't really tell me which bit of the problem space I'm in. And you can cut this any number of ways. For us, we found it broadly falls into three categories. There's document data, document-shaped problems. Those are pretty easy, pretty accessible. There's time series problems. And that's classically the metrics, the numbers you want to keep collecting and collect forever. And there's what I call forensic data, which is it's sort of like time series meets video. This is where I need to meet my client needs, and as a regulator, to meet the needs of the regulator, I need to be able to investigate something that happened 3 years ago in painful detail. So document problems, we're all familiar with this. I get about 15 spam emails a week from the various vendors telling me why to move to NoSQL for this reason. But document for me is a great solution for auditing and logging messages. I'd love to throw those all in a document database. It's loosely structured. The structures evolve. They are documents. They have some common themes, principle, who was the author, when was it published, when did it happen. But most of the rest of the stuff is very emergently structured. Our particular problem is a lot of that structure is still content sensitive. So again, because we're a regulated entity, we cannot just let someone go play. It is actually, we would have to report it if we found someone was just reviewing audit trails for no obvious reason. Because if you look at a customer's data and their trading habits and tell them what's going wrong, that's called customer service. If you look at someone's trading really quickly and put the order in at the same time as them, possibly slightly before them, that's called jail. So we need to know when people are looking at data. So I can't quite go to the, hey, no schema. I need to actually understand the data and still need to be sensitive to values. So what any old SQL people would have called row-based access control. I need to understand what someone is looking at, but I'd kind of like them within that remit to be able to look at anything. And I may even get away with some data loss. If these are message logs between coming in over the internet, the fact that I never received it or I never logged it, it can be negotiable in some areas. So there's more room for products there. In retrospect, sticking this in the same MySQL database was probably a mistake. It worked for a while. We could get really good insert rates. The query rates are truly horrible. That's slightly aggravated by MySQL's indexing policy, but basically, yeah, we made a bad call. 7 years ago, document database in NoSQL was not quite as proven as it is today, and we're currently rebuilding this. We're using the sort of Kibana Elasticsearch stack, so at the bottom of that, Lucene. And this is not a particular endorsement of the product, it's just a very nice integrated stack, and as long as we can get that content sensitivity sorted, I think we'll be happy. Time series, so faults, gauges, performance metrics. These for us are the big time series problems. I want to observe my system and how it's behaving. How often is it good enough to do that? No, votes. How often would you monitor CPU usage, memory utilization, cache exhaustion, message rates? How many times a minute? Second? It's a stupid question. I mean, there's no right answer, but it's really hard to know how much is enough. So here's the numbers, not terribly, what measuring isn't terribly relevant. It's, I can just about see that. Packets, if you can't read the text, it's packets per second. So this is one of those streams where we're looking at an individual client who was straining to keep up with market data. If anyone remembers A Few Good Men film, the big confrontation scene at the end between, who was it, Am I getting it wrong? Tom Cruise and Jack Nicholson. The big courtroom scene, and it's, I want the truth, and you're not ready for the truth. We have exactly the same discussion with clients about raw market data streams. We want it all, you can't damn handle it. And they can't on the whole. And it's just too much data for them to process, and when they can't handle it, what we get is, hey, network back pressure, but it's too late, it's out the door by then. If we're seeing it on the TCP stack, it is too late to react. So what we get are Win0 events in TCP. They're looking at data that's 10 milliseconds old because those networks can store a lot of data. There's an awful lot on the various switches that's still filtering down to them, and what they get are occasional bursts of high resolution, followed by increasingly aging data, followed by a gap. So we need to know on a single client basis to measure that, to detect this problem, and to help educate them and assist them with their needs. We need to understand at a very detailed level what's going on. And this is the fallacy of sampling. This is measuring data. The blue line there is counting packets per second, yeah, at a 1 second sampling rate. So an average number of packets over 1 second, sample every second. That sounds reasonable. For a laugh, let's have the green line. That's doing it at 100 milliseconds. And as you'd expect, there are spikes. Some of the 100 millisecond, some of the 100 millisecond periods in that second are more active than others. The red line is what happens if you put it down to 10 milliseconds. And this, again, this is fractal. This never stops. Really, you cannot know what's going on unless you look at all the data. Unless you've looked at all the data, you can't make the decisions about what you can lose and what you can aggregate and filter. And that's a hell of a storage challenge. This chart here, any of the FX traders in the room? Does anyone recognize the shadow of EBS and Reuters in there? This is the anatomy of this. That's a second of events. It's actually about 100,000 seconds overlaid on each other, counting incoming events from clients. And as you can see, we've got this 250 millisecond pulse overlaid with a 100 millisecond pulse, and within that there's a second 50 millisecond pulse, which is the Reuters feed coming across the Atlantic. Hence, there's more variation in the 50 millisecond pulse because there's variable latency in people receiving those numbers and pushing prices into us in response. There is no, it's short of doing some sort of fast Fourier analysis, which frankly, I can't remember how to do. I'm not going to detect those patterns. Looking at sample data, looking at averages, looking at means, I need every event. And I need something that is capable of storing every event to at least let me decide which ones to throw away. And forensics was our last challenge. Forensics is basically this for market data. I want TiVo for FX trading. I want to be able to pause markets, stop and rewind them, record them, go back and see what happened last April. Compare last April to this April. What was that interesting spike in the market? And this is for investigations, for client support, for fraud detection. Again, part of serving the clients here. We tried really hard not to write this ourselves. The event data, the time series stuff we store in LevelDB, that worked really well for us. That was pretty successful. Pretty simple time series analysis, nothing terribly complicated other than human review. We weren't trying to do inference about what happened in correlation. And we started here with LevelDB. We found we could get a mean throughput of about 350,000 events a second, which, great, that gave us 2 times headroom. But the compaction pauses killed us. Even with 2 times headroom, we could not go through that. Even the fact that we have after-the-fact analysis, we have less of a real-time requirement here. I just could not get this stuff to disk fast enough, or I say I, bravely, we, my team, could not get this to disk fast enough, reliably enough. So our second prototype, we looked at a product called Lightning Memory DB. Again, very good product, much better rates, headache to run with it. Again, at the time, things may have moved on, and I'm perfectly willing to accept some of this may be pilot error. By this point, actually, we pretty much knew the problem well enough, and yeah, we built it ourselves. We have a habit of doing that. Our production system, under the same benchmark, was running at 6 million transactions, events a second, and that's not because we are smarter than these guys. It's because we were building a purpose-specific solution for a problem we understood very well. The other products are far more general purpose. They have to deal with things that problems we didn't have. We knew, for example, the data came in time sorted. That's a huge win if most of your access is by time. We also have transaction IDs that are covariant with time. They monotonically increase with time, as does time. So we have a huge insight into the data. It allows us to build data structures and solutions that work much better than general products. It's not because we're product averse. Actually, this was the easiest way to do it. So what we have ended up with is quite a massive diversity of storage solutions. We've got really more software in our inventory than I would happily like to maintain. It would have been lovely to find the Holy Grail or find the one ring to sort them all out, take away the pain, take away the problems, We couldn't do that. And I'm not convinced we could do that today and meet the service levels we expect. And if either of those films have taught us anything, it's that we probably shouldn't try. If bringing this back to what we've been talking about in terms of reactive systems, if I'm thinking about multiple separate systems, multiple components, talking separately, dealing with their own needs, responding to and emitting events, cooperating in a distributed network, then the idea of some sort of, under this is our monolithic data layer, that's just a bit out of date. It doesn't really seem to fit at all. And I think the other thing we've learned is the problems are never the ones we are looking for. They were always somewhere else. The sexy and appealing and interesting stuff, the obvious things that came up in week one when you're doing the big plan of the breakdown, wasn't where the hard stuff was. And this, to me, was a complete misapplication of TDD. So I've kind of been converted to TDD. The first thing, sitting down with the developers, and they told me, right, how are we going to test this? We did not ask ourselves that when we set out to run a 100,000 transaction a second trading system. If I had first asked, how am I going to measure that? It might have changed my priorities a little. Thank you.